So welcome to our third webinar in our webinar series focusing on innovative projects funded by different EU programs. So besides polynSPIRE project that we present today, we also talked about the METO and upskill projects back in February and March. So these webinars are organized by Polymer Comply Europe, PCE, on behalf of Europe Plastics Converters. And our topic today is boosting the circular economy in Europe. And as I said, as you are all aware, we will present polynSPIRE project, which is abbreviation for demonstration of innovative technologies towards a more efficient and sustainable plastic recycling. So a few words about the polynSPIRE project. This is a Horizon 2020 project that started in September 2018, and the envisaged duration is 48 months. The project involves 21 partners that include research academic institutions, governmental organizations, industries, and SMEs. And the total budget of the project is almost 10 million euros, and EU contribution is 8 million euros. So EUPC and PCE are in charge of the communication and dissemination activities for the polynSPIRE project, and the webinar is one of our communication activities foreseen in the project. So it is my honor and pleasure to welcome Dr. Tatiana Garcia. She's a project coordinator for polynSPIRE project. A few words about Tatiana. She's a senior researcher and director of Energy and Environmental Group of CIRCE Foundation. She's a chemical engineer and holds a PhD in engineering from the University of Saragossa. She has both national and international research and industrial experience, including a research stay at Imperial College of London in the UK. She has 14 publications, accounting more than 370 citations. So developing her career in the research and innovation field, she has gained very valuable experience by executing, leading, and coordinating relevant activities in a broad range of innovative projects, all of them that are related to efficient resource management and circularity enhancement, the use of alternative resources, including sustainable raw materials and renewable energy sources, design and validation of innovative process towards a more sustainable industrial sector. Diagnostic methods and predictive models apply to the monitoring of various energy and environmental parameters. In addition, she has experience in training and teaching activities with a focus on the circular economy and life cycle analysis. CIRCE Foundation, the place where Tatiana is working. So this is a technology center founded in 1993. Seeking to provide innovative solutions for a sustainable development. This research center has a multidisciplinary team composed of more than 180 employees. So I would suggest now, after this introduction, that we go ahead with the presentation. As you saw in our agenda, we're gonna just briefly present the CIRCE Foundation, and then we're gonna move on to our polynSPIRE project. So some general comments and the latest developments. Tatiana?
Okay, thank you very much, Marian, for the introduction. Thank you to Polymer Comply Europe for giving us the opportunity to perform this webinar. And also thank you to all the assistants to give us the opportunity to explain a little more about polynSPIRE and about the things that we are doing. So thank you very much. So as Marian said before, I'm going to start a little bit with some insights about CIRCE Foundation, which is the Research Center for Energy Resources and Consumption. As Marian said, we are set in Zaragoza, Spain. And we are a technological center founded more than 25 years ago. And we are plenty focused on sustainable development. We are more than 180 professionals from the fields of the engineering working together to build a more sustainable world, focusing on renewable energy, circular economy, and also the integration of new technologies with the purpose of generating a technology transfer to the society by means of research and innovation projects, but also using our technology transfer activities to private companies, and obviously the training, because in all the issues related with innovation and research and improving the sustainability, training is also a must. So we, apart from being a technological center, we have also a private foundation. We have several patrons covering different business lines in Spain. We have a public organization like the local government of the university and the University of Zaragoza, and we have also some members which comes from the private sector, focusing on electricity and production and distribution, also agro-industry, industry sector, obviously, manufacturing, electronics and IT technologies. Here are our numbers about the progress in research, the number of projects. We have three main pillars of activity. The first one is research. Here we work in a lot of European, and not only European, also national projects focused on research and innovation. At this moment, we have 66 Horizon 2020 projects running. 21 of them, they are coordinated in our different thematics of work. We have also a second pillar, which is more focused on transfer services to the private companies in order to put the research and innovation into the market, because we are extremely market oriented, because this is the way to solve the problems in society. And as I said before, we have our third pillar focused on education, covering not only education for people who are working in companies which are interested in our services, but also we are collaborating with official studies and masters from the university. So focused on research, we work also in other type of programs, like for example, national programs focused on innovation at the Spanish level, and also other European programs focused on other countries. Just to give you a figure about the magnitude for our activities, during the last year, we have been achieving more than 100 million euros of public funding, not only for CIRCE, but also for our collaborators in the different projects that we are coordinating in Horizon 2020 and also the 7th Framework Program. So giving more insight about our activity lines, we can summarize our activity into 6 main lines of expertise. The first one is more focused on renewable energy. We have a huge expertise on wind and solar energy, but also biomass and the integration of renewable energy into the grid, because it's also very important to have into account the issue related with flexibility and integration of renewables into the grid. We have a lot of activity in our second line, electric grids, focusing on smart grids and power electronics, on energy storage, also something which is also very relevant in the case of renewable energy. We have a third pillar of activity focused on smart mobility, electric vehicle, and also sustainable mobility in cities and countries. We have other 3 pillars more focused on industry and building energy efficiency and sustainable development, covering Industry 4.0 activities, addressing monitoring, ICT activities, also combustion improvement, predicting activities, big data or machine learning issues in order to cover all the Industry 4.0 field. We are also working on energy efficiency, both in the industry and agro-industry sector, but also in building and construction, because buildings are one of the main consumers in terms of energy nowadays. We obviously, in projects like polynSPIRE, covering circular economy and sustainable issues in our projects, focusing in energy use and efficient energy use and resource consumption, also waste reduction, emission and pollutant reduction, and sustainable evaluation, focusing on life cycle analysis from an environmental, economic, and social point of view. CIRCE has a good or a huge internal vocation. we are working in several countries from the United States to Japan, China, South Africa, or Latin America. Our headquarters are in Zaragoza, but we have 2 other delegations, one in Madrid, which is one of the main cities of Spain, and also one delegation in Brussels, who allows us to have to be near to the European changes and the European activities. Finally, more related with our international positioning, we are participating in several associations and platforms, focuses in our main fields of activity: renewable energy, energy storage, bioeconomy, circular economy, and also SPIRE platform, which is the Sustainable Process Industry through Resource and Energy Efficiency, which is the program which funds polynSPIRE project. So up to this point, these are the main insights about FIRTE Foundation and our fields of activity. And now we are moving to the polynSPIRE presentation, explaining the main goals and challenges into the project, and also which is the current status of the project, some future key points that we are going to cover in the following months. So just to start, some general facts and figures that have been already presented by Marian. As Marian said, our project started in September 2018. We are almost in the middle of the project, but we have 48 months to cover all the activities and all the demonstration pilots. We are 21 partners covering different profiles of industry institutions. Our aim is to achieve a TRL 7, which is a technology readiness level, which implies the building up of a system prototype who needs to be demonstrated into the operational environment into the industry. So giving some information about our consortium, as it's very relevant for any kind of project to focus on circular economy, we are covering all the relevant actors along the value chain of the plastic sector. We have into the project some technology developers. Apart from FIRTE, we are also collaborating with the National Institute of Chemistry of Slovenia, Ionica, Technical University of Eindhoven, and also RINA. We have also waste managers and providers, such as IT of iBlue in Italy. We have also obviously end users and validators at different points of the value chains, from the chemical industry such as Nurel, Corsa, Novamon, Arkema, Repsol, from the final users of our products, like for example, Bada, Bayer, or Ferrier Nord. We have also technology providers and manufacturers such as Fricomala, CPP, or HTT, who works as engineering within the project in order to build up the prototypes. And we have also partners who cover the most transversal activities, like dissemination, communication and standardization activities, as the DENX standard, UPC, or ICMIP and Charky. So moving in detail about polynSPIRE, so where is the problem? Sometimes when we think about plastic, nowadays there are a lot of news about plastic, the need of reduced plastic use, the needs of reduced plastic waste, but we will need to think about the real magnitude of the problem. At this moment, the consumption of plastic in Europe in 2019 was more than 50 million of tons of plastic, which accounts the 14% of the worldwide production. But it's not only a problem of plastic use, but also about the amount of waste generated due to this plastic use. In 2019, we generate almost 30 million tons of plastic waste. But what happens with this plastic waste? The problem is not the use of plastic, but the end of life of this plastic waste that is generated in different points of the value chain. Even we are continuously making some efforts about improving the circular economy of the plastic value chain, and also to increase recycling strategies. We have that around 30% of the total waste is still landfilling. So this is something that we need to manage in order to achieve the objectives in the plastic sector. Other relevant issue that we will need to take into account just to understand the real problem is where the plastic is used. As we can see in this figure, the big percentage of plastic used in packaging activities, but we have also other sectors more focused on automotive, construction, engineering, or even agriculture, electrical or electronic device that they are using plastics. The main problem of this type of sector is not only the use of plastic, but also the mix of plastic that they are using, which totally hinders the proper recycling. So before starting with the explanation about polynSPIRE objectives, about polynSPIRE goals, I would like to give some, or to put here some open questions about the plastic problems that they are very relevant and we will need to think about it. The first question is it possible to build a world without plastic? From our point of view, no, because plastic brings a lot of advantages to the engineering and to the automotive sector. For example, how many lives has plastic use saved? The use of plastic in automotive have reduced the weight of the cars in this case, but we have also introduced some safety devices, for example, airbags or other components in cars. Other issue that we need to think into account, to take into account is the real relation between the weight of the cars in this case, and also the fuel consumption. The use of plastic in cars has reduced a lot the weight, and consequently, it has reduced a lot the use of fuel for these cars. And finally, which are the advantages that we obtain using smart plastic materials, composites, or fillers, fibers, additives, in comparison to conventional ones. So the question here is, we cannot eliminate the plastic, we shouldn't eliminate the plastic weight, but we will need to think about how to manage the plastic weight in a proper way, just to take the most from the plastic waste and to reintroduce again plastic into the value chain. And at this point, is where polynSPIRE is working on. So European Commission has published different guidelines or different action plans about circular economy objectives, about how to improve the efficiency and how to reduce the waste generation. polynSPIRE is totally supporting this effort by introducing a set of novel approaches to recycle and to increase the reuse of plastic waste as new raw materials. So focus on the main objective of polynSPIRE, we are aiming at demonstrating at TRL 7 a set of innovative, cost-effective, sustainable solutions with the aim of improving energy and resource efficiency in the plastic recycling processes. We are mainly focused on polyamides and polyurethane. They are two of the polymers that are using in these other applications related with engineering or automotive, the matrices sector, which is another relevant issue because the amount of bulky waste that is generating. And we are addressing to two types of plastic waste, both post-consumer, that is at the end of life of the products, but also post-industrial, because in this sector, the amount of waste that is generated after the industrial processing is also quite relevant. But when we start working on polynSPIRE, we also need to think about the current challenges and the existing barriers to achieve our objectives. We can divide our barriers into main topics, which are the technological barriers and also the non-technological. Focus on technological is important to have in mind that the evolution into the engineering sector and to the plastic industry has introduced a lot of new materials, new plastic compositions, the presence of additives, paints, flame retardants, mix of plastic composites, fillers, fibers, that totally hinders the recycling process. Also, the already existing sorting technologies are not able to sort this material in an efficient way in order to ensure the proper recycling. And in addition, we have also another limitation. When we are thinking about high-level application or high-requirement applications such as automotive, aeronautics, and so on, mechanical recycling has the problem of reducing somehow the mechanical properties of the recycled material. This can be translated into the downcycling of the recycling process. And we will need to improve the existing technologies in order to ensure that the final quality of the recycled material is good enough to be used in high requirement applications. And on the other hand, we have also non-technological barriers. On the one hand, plastic waste is generated at different points of the value chain. So if we are not able to ensure the traceability of the information, it's very difficult to know what happens with any kind of stream of plastic. And this could totally also hinder the proper recycling. And we have also another issue related with the standards, which are not homogeneous alongside Europe. We will need probably more or new the standard for recycled material content and also quality. And other issues related with regulation, for example, the transposition of the waste directive, can also make difficult some changes on some activities within the plastic value chain, especially when we are dealing with multinational companies that they supply their product to different countries with different regulation and different restrictions. So considering all of this framework, polynSPIRE is proposing a redesign of the value chain, covering 3 different innovations. The first one is the innovation focused on the chemical recycling. This innovation permits the reintroduction of plastic waste as monomers into the very beginning, into the beginning of the value chain. We have also some innovations in mechanical recycling in order to improve the quality of the mechanically recycled materials, just to meet the requirements in terms of mechanical properties or resistance. And finally, we have a third pillar more focused on valorization and industrial symbiosis with the steel sector, which aims at reducing the use of coal in electric arc furnaces, and also to reduce emissions in this type of furnaces by the use of plastic waste. So this is more or less our value chain, or our new proposed value chain. As I said before, we have partners covering different parts of the value chain because it's very relevant to take into account the point of view and the requirements of all the stakeholders in order to build a solid and stable value chain. We start from the chemical industry. We have compounding part. We have high performance applications which require some upgrading of mechanical recycling. And we have also another relevant part, which is the sorting system, in order to meet the requirements of the different technologies to ensure the efficiency of the recycling and also the quality of the monomers and a proper isolation. Going in more detail about the different innovations, regarding chemical recycling, we are proposing 2 different technologies in order to reduce the energy consumption and to improve the selectivity and the sustainability of chemical recycling. On the one hand, we are proposing a chemical recycling assisted by microwaves. The advantages of using microwave in chemical recycling is the fact that we are reducing the energy consumption from the chemical recycling, but because microwaves can be selectively heated up the mixture, and also to reducing the times of processing, which has a very good relevant impact in terms of sustainability of the solution and also in terms of economic feasibility. The other innovations in chemical recycling is the use of smart magnetic material. This is a type of materials that they are quite special because they have some magnetic properties that they are very, very selective of catalyzers, so they provide a good result in terms of the selectivity of the polymerization reaction. At the same time, due to having magnetic properties, they can be recovered by using a magnetic filter, which also increase the circularity of the chemical recycling, reducing the use of catalyzer, which is another relevant problem that can hinder the sustainability of the process. On top of that, this type of materials also allows the working at milder conditions, which also has very relevant impact on energy consumption. So moving to the other pillar, focus on mechanical recycling. As I said before, the idea is to work with different technologies in order to improve the properties, especially the mechanical properties of the recycled materials. Here we are dealing with 3 different innovations. The first one is focused on bitrimmers. The idea of using bitrimmers is to make some additives into the mix that need to be processed by mechanical recycling in order to improve the mechanical properties, to improve the resistance and the strength of the material, at the same time that this is reversible. That means that it's not affect the future recyclability of the plastic material. A second innovation within mechanical recycling is the use of different compatibilizing additives that improve the properties in terms of aesthetical or organoleptic properties of mechanically recycled material. Because another problem, especially when we are looking for application in the automotive sector, is also the appearance of the appeal of the recycled material in terms of color, in terms even of odor. So this type of compatibilizer additives can improve these properties. And also we have high energy radiation, which is another way to improve the mechanical properties, to increase the resistance this resistance of the materials. And also this has also the advantage of being compatible with the existing equipment. So it's a kind of extra step that can be applied to the materials, but it's not affects to the manufacturing lines, which is another very positive point, just to ensure the proper replicability of the solution into the plastic sector. So, and as a third point, we have the valorization of plastic residues into the steel sector. Here we can use low-grade plastic or plastic that can be sorted by another technology. The only limitation is a kind of ratio between the carbon and the hydrogen content of the plastic, and also avoiding some components, as for example chlorine, that can produce some pollutant emissions. And the idea is just to introduce this plastic mixture into electric arc furnaces in order to remove the use of coal in this type of furnaces in order to produce the steel. And also they have this plastic have the property of protect the steel which is melting. And also it's very flexible to plastic composition. So we can have good results in a wide range of composition and plastic types. So, which is your impact? Considering all the demonstration of these activities, we are aiming to address waste streams that contain 100% of plastics. Also, mainly polyamides and polyurethane, as I said before, but also another type of plastics. Our idea is to achieve a reduction of CO2 equivalent emission in the sector between the 30 and 30% of emissions alongside the life cycle of the project. Finally, with a proper exploitation of the activities, our idea is to be able to propose a technology that can treat at least 50% of the plastic waste existing in different plants of Europe, achieving a very huge impact and relevant amounts of not only CO2 saving, but also fossil fuel used, and also reducing the amount of waste that is landfilling, which is another relevant problem for the plastic sector. Which is our compromise in terms of individual impacts of our technologies. We are aiming at addressing between a 60 and 70% of efficiency increase in chemical recycling, which is one of the main limitations of the current technologies of chemical recycling in order to make them feasible from an economic point of view. We also want to reduce the processing time of chemical recycling in order to give a better reply to the problems of the industrial sector. We are also aiming at improving the mechanical properties, increasing the mechanical recycling between 10 and 20%. And we are aiming at substituting around 80% of coal into electric arc furnaces. All of this together with dedicated business model, because these new innovations into the plastic value chains are going to bring the new business models and new relationships between the different parts of the value chain, and obviously having in mind the requirements in terms of changes of regulation and also standards that can promote the circular economy into the sector. when I make this general overview about polynSPIRE, objectives, challenges, and our main barriers, I'm going to present you a little bit, which is the current state of the project, which are our main findings at this moment, and also our future steps. So if we think about the lifetime of our innovation, we can divide in our project in different stages. We started with a first on analyze the real problem, analyze the requirement of the industry, and analyze which are the main barriers to achieve our objectives. As soon as we have all the problem perfectly defined, we move to the analysis of the possible solution, which will be the better configuration of the different technologies in order to meet our objectives. And as soon as we have different solutions, we are moving to the design of the different innovative solutions, starting with a conceptual design and obviously the engineering and prototyping part. Then we will move to the startup and optimization of the technologies, the upscaling, and finally the market development. All of this technical evolution of the project is also in parallel with the analysis of the standardization need, as I said before, the creation of an exploitation plan and a market analysis focused on addressing the main barriers detected, and obviously all the issues related with intellectual property. Given more details about the technical developments and the main barriers that have been detected, at this moment we have validated all the technologies at lab scale. We have very good results for the different polymers. Obviously, some of the technologies are better from polymers. We have also demonstrated that fibers can be successfully recovered from the complex materials. And after the recovering of fillers, we can move to the recovering of the monomers. Moving to the mechanical recycling, we have also seen that we can expect good results in terms of the use of e-trimmers, especially for upgrading polyurethane materials. Whereas the technology based on high energy radiation seems to be better to upgrading polyamide plastic materials. And regarding with the steel sector, we are in a very good progress with the design of the dedicated injector to be flexible and to introduce different type of plastic, not only plastic, but also byproducts from plastic production into the electric arc furnaces. And regarding the non-technical barriers and the non-technological progress, we have defined, we are working on defining the future scenario of plastic production alongside Europe. We are elaborating a map of plastic waste generation alongside Europe in order to detect the requirements in terms of infrastructure and in terms of logistics, which is another relevant issue to take into account to close the loop into the plastic value chain. We obviously need to analyze health and safety protocols, not only the existing one, but also detecting the needs of creating new health and safety protocols, because we are developing new technologies and a new technology could bring some health or safety issues. We are also working on the standardization landscape in order to explore and to see any kind of initiative working on standardization, not only on the use of plastic waste or of the new technologies, but also in terms of circular economy metrics, because another issue which is relevant for plastic recycling is how to measure and how to define the proper metrics in order to select the most suitable indicators should be comparable at different stages of the value chains in order to work using the same rules. Finally, as a comment, we are obviously continuously in contact with industrial stakeholders, not only within the project, but also consider other stakeholders outside from the project, because it's very relevant to be updated about the real needs and the evolution of requirements of the industry. Just these pictures and some examples of this exploitation events with the stakeholders. Some of them was at the beginning of the project in Zaragoza during the kickoff meeting, but other even we have also organized an event in Turkey with the industrial sector in Turkey with a very good audience in order to give this feedback about the real problems of the society. Just to give you finally some insight about the future steps, which are our key actions for the next months. Here you could see the evolution of the lifespan of the project. We are working on different phases. As I said before, we are covering the phase focused on the consolidation of the lab scale, and we are moving to TRL 6, from TRL 6 to TRL 7 by demonstrating and testing our technologies into at different levels of relevant environment, just to finalize with the demonstration at industrial level. One or some of the open questions at this moment that we are working on is how can impurities of mixing in the waste stream can affect to our technologies. Also, how we can optimize and make feasible of the technologies. We will need to find a compromise between the environmental aspects and the economic issues, just to ensure that our solution can be exploitable and can be introduced into the market. We are also analyzing some requirements in terms of pretreatments on the one hand, and also in terms of isolation and purification of our products. Finally, my colleague Marian are going to give you some information about new events that are coming, and they are very interesting in order to gather the expectations of the industrial sector.
So thanks a lot, Tatiana. So first of all, we have a conference that was envisaged, of course, in May, but we decided to move it for 14 October. I'm just want to let you know that this is tentative. We'll, of course, monitor the situation. If there is a need, we'll maybe move it also online. This is a plastic circularity multiplier. So it's a, let's say, 10 plus Horizons 2020 projects that are working in the same research field. And also polynSPIRE is part of this multiplier. You have opportunity to register for this conference. There is a link, and of course we will share the presentation so you will be able to do it. The second conference, Tatiana, just, yeah.
Yeah, sorry.
The second conference is the second European Chemical Recycling Conference. So Tatiana was a guest speaker at the first one that we had last year. Also, this conference was envisaged to happen in May, but due to the well-known situation, we decided to move it for September. But of course, we'll monitor the situation here as well and react if there is a need to maybe postpone it for next year or maybe do it online. But you also have an opportunity to register here, and you will be notified about next steps and possible date for the conference.
Okay, thank you, Marian. And just to finish, I will also take the opportunity to make some diffusion of another issue that we are moving from CIRCE. That this is a special issue into the journal Sustainability, which is focused on gathering some papers and some scientific work related with the circular economy evaluation, because I said before, the evaluation of circular economy and the traceability of information is a must to meet the requirements in terms of circular economy, and also to achieve the goals from the European Commission in terms of increasing recycling rates, and also reduce the use of fossil-based material and reduce the use of resources. This is a special issue, as I said, focused on combining the approach of circular economy with the life cycle perspective, also very relevant for the analysis of the value chain. The initial deadline was September of this year, but we have decided to extend the deadline till January of the next year, just to be able to gather more papers and more contributions. So all your works and all your contributions will be more than welcome. And if you have any questions regarding with this special issue, please don't hesitate to contact me.
Okay.
Just to finish, to give you to all of you, thank you for your attention. And now I think that it's time to questions.
Yes, exactly. Thanks, Anna, for this presentation. I think it was well to the point. We also shared some of the developments when it comes to the project. So according to agenda, we are moving to the Q&A section. So I would ask all the participants that they would like to ask the question to use the opportunity now. You have a small window there when you can type your question. I will read it to Tatiana and we'll be happy to answer. So beforehand, we received a question from Davor Krnić from Plamegal Trio in Croatia. So pyrolysis of waste polymeric material is one of the ways of chemical recycling. During this process, liquid fuel forms, so pyrolysis oil. Is there a possibility that the electricity produced from such a fuel, so waste to energy, could be considered as energy from renewable resources, or so to say green energy? And is there a way to achieve a higher redemption price, so supported? I'm guessing that was.
Okay, thank you, Martin. I think that the question is very interesting, and it's very important topic regarding with the objectives and the metrics of plastic recycling. Here I have to say that we need to move to the official definition of the renewable energy sources. We can check this type of definition in platform, like for example, the Zero Waste Platform of Europe. Here the definition is very clear. Renewable energy needs to come from renewable sources, which includes obviously wind, solar energy, but also biomass. In case of waste, there is a more, let's say, controversy about the definition. At this moment, it's not included as renewable sources because it has some content of fossil-based material. But answering the second part of the question regarding with giving or having some profit for the use of the electricity from pyrolysis, what we can consider here is if you are using this type of electricity of self-consumption, we are avoiding the use of electricity from grid. So this can be translated into some environmental profits in terms of CO2 emission and reduction. And we can think about having the profit from this side, but not as being renewable because it cannot be considered renewable.
Okay, thank you. We're gonna now move on. We have a question about Ionica. What is their role on the project? More specifically, are they helping or they are actively involved? I'm guessing they're asking if they are partners or they are in a subcontracting role here.
Could you Ionica, they are partners of the project. They are fully partners of the project. And they are the work package leader of one of the innovation focus of the smart magnetic materials technology.
Okay. Then are those solutions for mechanical recycling also can be adapted to PET and polyolefins?
We have seen that there are some, let's say, evidences about the extrapolation of this type of technologies to another type of polymers. In this project, we are focused on polyurethanes and polyamides because they are our main goal. But the idea was also to provide some insight to the extrapolation of the technologies to other technologies, that, for example, to other materials, as for example, PET. So our first results seem to indicate that we can use it in other materials. Obviously, we will need to think about which are the real efforts in terms of property, rheology, and so on. But the idea is just to think about the extrapolation to other polymers.
Okay. Then we have a question from Daniela with regards to chemical recycling technology. Which one is the most promising?
At this moment, the result that we have is each of them are more promising for different types of polymers. For example, in case of polyamide 6,6, polyurethanes, microbes is giving, I see slightly better results, but for case of polyamide 6, smart materials seems to give better results. So now we are in a very early stage of the project just to confirm the final evolution because we will need to upscale the solutions. But at this moment, each technology is more promising for different type of polymers. So from my point of view, they are in a similar level of promising, but it depends on the polymer.
Okay. More question from Daniela in terms of economic competitiveness on the market. What are the objectives of recycled plastics with a chemical process?
Okay, this is another relevant point from the chemical recycling, because one of the main obstacles and limitations of chemical recycling is sometimes the economic feasibility. And this is why at this stage of the project, we are very focused on try to reduce the energy use and try to optimize the energy efficiency of our process in order to ensure that the savings in terms of energy can cover other extra costs related with chemical recycling. And our idea, our initial goals was to achieve a technology which can be with a payback period less than 4 years, just to make the solution economically profitable.
Thank you. We have a question from Ariel. Are you aware of the Circular Plastics Alliance?
Yeah, we are collaborating with the Circular Plastic Alliance, and we are working with the Plastic Multipliers initiative, which is very positive because bring together a lot of people working in innovative projects focused on circular economy promotion.
Okay, thank you. Eva Maria says, thank you so much for the great presentation, very interesting. Do you have any collaborations with industry partners who develop new products which could be returned in a technical way of a biological cycle? Products which do not need complicated recycling techniques and energy consuming process, products following the cradle-to-cradle principle founded by Professor Braungart.
So at this moment, we are focused on other routes different from the biological one. We are totally aware that biological route is very promising for certain types of plastic, but this is not the main focus on our project. Obviously, our idea is just to provide a new set of innovative solutions that can be compatible with the existing one or even with other that can arise in the future.
Okay. Lane, would like to know, did you already do an LCA analysis for different innovative technologies? Would be good to compare with virgin polymer production, mechanical recycling, and incineration.
The idea of the project is just to make this type of analysis for the innovations that have been developed within the project. At this moment, we are characterizing the baseline, which is the use of conventional technologies for plastic recycling, just to have the baseline for comparison. But I can also add that we are working on this type of analysis in other projects. And obviously in this type of project, we can also have some comparisons between the innovation on the innovative routes for plastic recycling and the baseline conditions. Something that is important to highlight in this point is when we are performing a life cycle assessment, we have a huge range of indicators. We can cover more than 18 indicators. So sometimes some of the technologies are good from some indicators, but they can, let's say, produce bad effects on the other indicators. But in the general analysis, we consider an optimization of the value chain, and also a monetization, for example, as a methodology to have a single indicator for the environmental impact. Obviously, recycling is always better than the linear economy, and we try to optimize our technologies in order to minimize the environmental impact.
Okay. David Walsh would like to know, are you still considering other mechanical recycling technologies, or is it closed?
So at this moment, the goal of the project and also the consortium is closed because it's a project that has been already funded more than 1.5 years ago. But obviously, we are always looking for synergies for new products or for new projects or for future collaboration. So this is something that we could discuss, but more for future initiatives.
Okay. So feel free to contact Tatiana then for any future presentations. Gregorio is interested in knowing if you are dealing also with PA composites and PU foams as sources of plastic waste for the processes to be studied.
Okay, thank you. For this project, PE composites out of the scope of the composite that we are dealing in this project. But polyurethane foams, they are totally into our goal. So this is one of the main type of polyurethanes product that we are dealing with within the project. We are working on polyurethanes foams.
Giovanni would like to know what materials are tested in the chemical recycling.
In chemical recycling, we are going to test both type of material, polyamide-based materials and polyurethanes. Focus on polyamide, we are mainly addressing polyamide 6 and 6,6, but our idea is also to make some experiments and some tests with longer chains polyamide, in particular polyamide 10, 11, and 12.
Okay. Carles is asking if there is any experience in removing flame retardants from polymers to be recycled.
This is exactly at this moment of the project we are dealing with this issue, because we are totally aware that flame retardants can hinder somehow the proper chemical recycling, and now we are making some experiments with different compositions of complex products, including obviously flame retardants, in order to be sure that if our technology is able to deal with them, also in case it will be necessary, just to provide some guidance about the types of flame retardant that can be treated without technologies, the type of flame retardant that needs to be avoided.
Okay, we have one technical question regarding Horizon 2020. So Nishat would like to know, can companies based in North America participate? Since the program has already started, will a new program begin with new applicants? I think I can also answer this question.
Yeah.
So after Horizon 2020, we will have Horizon Europe. I think the calls and programs, draft programs were already published. There are some calls that external partners, meaning partners not from Europe, can participate. I think that CIRCE is definitely open to collaboration, so feel free to contact Tatiana for the next steps.
Yes, something else to add. We about any kind of other programs that can be working together with North America, or even some types of some 2020 projects have type of collaboration which is called a twinning, which can, let's say, make some kind of collaboration between projects from both sides. But in any case, we can discuss future collaboration, obviously. Okay.
Manuela would like to know about CO2 savings from the presentation. Is wondering that 30 to 40% savings is compared to what?
It's compared to the amount of CO2 emissions of using virgin polymers. This type of impact has been calculated in considering the baseline, which is the using of virgin polymer, and which is the percentage of reduction if we use recycled polymer instead of virgin one. Also, obviously, considering the emission related with the recycling process.
Okay. Albert from Netherlands is asking how chemical recycling with any other company. Is collaboration with Fraunhofer possible?
Regarding the companies that we are collaborating, we are working with the companies that have been presented into the representation. In the demo site that we are performing within the project, we are focused on automotive sector for polyamides and the matrices sector for polyurethanes. And regarding the participation of Fraunhofer, as I say before, at this moment the consortium is closed, but obviously we can think about future collaboration of synergies with other projects.
Okay. Manuela would like to know if the LC analysis was done. We answered that question, and how you measure the savings.
The saving has been measured by the application of the life cycle assessment methodology. We translate the emissions of CO2 by means of the indicators of global warming of recipe method of environmental analysis.
Okay.
probably the question is related with the comparison between direct emissions and indirect. When we are applying a life cycle assessment, we consider both direct emissions of the technologies, but also the indirect emissions due to the use of fossil-based materials, electricity, and so on. And when we are talking about 30 or 40% of CO2 equivalent, we are referring to the whole life cycle, not only direct, but also indirect.
Okay. Luis would like to know, from the slides, I understand that the project is focused on PIPU. How are products made from these polymers separated from waste streams, and from which waste streams particularly?
Okay, at this moment we are starting working with post-industrial waste, which is easy to shorten out because all the industrial companies preferably know which is contained into the waste, and it is easy to make this separation process. And our idea within other activities related with roadmaps and guidelines is just to propose the needs for sorting in conventional sorting systems.
Okay, Laura, as before the recycling technologies, how do you sort the materials from the plastic mix?
This is related with the previous question. We don't have this. We don't develop new sorting methodologies within the project because we are mainly focused on the recycling stage. But we obviously know that the sorting process is crucial for ensuring the safety, to ensuring the efficiency and the quality of the materials. And this is something that we are going to deal with in more theoretical way, just to analyze the existing sorting technologies and also to propose the most suitable one. And in case needed, the new requirements for the sorting technologies.
Okay, we have Vincent who would like to know, what do you think that lifetime durability must be the key issue for recycled plastics and thus for circularity?
Okay, life span of the product is a key point, because the longer is the lifespan, the most difficult is to follow the plastic and to be sure about which is the different activities that have been taken along the lifetime of the plastic that can hinder the future recyclability. This is why in one of the activities, especially focused on mechanical recycling in some of our work packages, we are also going to analyze which is the effect of aging of the samples into the recycling quality.
Okay. Manuel would like to know, which is the present status of polymer ejection into the arc furnace? It has been already implemented into the normal steel melting. Is it already implemented into the normal steel melting cycle of the furnace?
At this moment within the project, we are on the phase of the engineering of the injector. We have made some tests with lab scale injector, and now we are building up and scaling the injector to be used into the steel sector, into a real electric arc furnaces at full scale in an industrial site. Probably in 1 year, in a half, we will have the first result for these activities.
Peter Wilms asks about different types of polymers. So can our approach also be applied to PVC?
At this moment, we are not dealing with PVC. As far as we understood, PVC have other problem, which is the presence of chlorine that can, let's say, produce deleterious effects on catalyzers, and also some emissions regarding with chlorine that can be dealt with a very careful way. So at least during this project, we are not going to deal with PVC. Obviously, we will also consider the presence of PVC in a small quantity in some plastic waste streams, just to be sure about the effect, but we are not going to focus our analysis into PVC.
Okay, thank you. Mikhail would like to know some more details about the entire concept of using smart magnetic materials in the chemical recycling process.
Okay, I'm not sure what type of details did you need. So Obviously, this is a development which is performing by a company within the project. They are working in developing new catalyzers and new smart magnetic materials, and also to improve the technology that they are using for other type of polymers, to demonstrate that this technology is able to be used in polyamides and polyurethanes. But there are obviously some confidential issues that cannot be shared to the public audiences at this moment, because they are also working in some patents and EPR protection.
Okay. Peter would like to know what would be the scale that is envisaged for the demonstration. So how much tons, I'm guessing?
Okay, we are thinking about, in the case of the chemical recycling, of scales above 500 liters of reactors, in order to be able to deal with at least 100 kilos per batch of plastic in each batch. And when we are moving to a mechanical recycling, our demonstration will be also focused on hundreds of kilos for the different technologies. And in the case of the electric arc furnaces, the idea is just to use a real electric arc furnace into the premises of Ferry Renault, which is producing steel. So this is a full industrial size.
Okay. Gurkan would like to know, can all monomers be obtained separately in chemical recycling of the polymer plants?
Yes, the results that we have at this moment, we obviously know that we will need an isolation and purification state, but we are recovering monomers with a very good level of quality and percentage of isolation.
Okay. Giovanni would like to know, with PA and PU, did you reach a separation from monomer to the additive at the end of the process?
Yeah, this is related with the previous question, and for both cases, in case of polyurethane, we are able to extract the polyols to be used for the generation of new polyurethane foams. And in the case of polyamides, we are able to isolate the different monomers. In case of PA6 and PA6s, we are able to isolate with a good purity caprolactam, isamidylamine, and also acidic acid. So we are having good results in terms of isolation and purity of the single monomers.
We have one more question from Nives. So the Circular Plastics Alliance that was mentioned has set ambitious goals for 10 million tons of plastic waste to be recycled by 2025. Are any of the technologies up to the scale to cope with this expected commitment?
Okay, apart the technologies that are being developing in polynSPIRE, there are a huge range of projects working on different technologies which are more suitable for other type of polymers. We have chemical recycling for PET at a semi-industrial scale. We have also some other companies that are working on pyrolysis or on other processings in order to cope the objectives of the Plastic Alliance. I think that we will need to work together. And this is why it's very relevant initiatives like Plastic Multiplier, because each project contributes to achieve the objectives for some of the polymers, but we will need to work together to achieve the goals and the results.
Okay. I would like to know, and I think this is also an important question, what business models are you considering?
Okay, at this moment we are working very closely with obviously with the partners of the consortium, but also we are exploring the requirements in terms of different stakeholders along the value chain, and also regarding the standard and regulations, because thinking on business model, if we need to achieve the objectives in terms of recycling, we will need to collaborate alongside the value chains. Probably we will need to change the model of our waste managers and to think about create specific installations to the polymerized process in case of chemical recycling, or even to add additional activities for upgrading the mechanical recycling. Or even we can also think in the other side of the value chain. Probably chemical companies could be interested in introducing some stages for pre-processing focused on chemical recycling in order to produce their own raw materials.
Okay, thank you. From Vasilius, we have a question. Is the project open to create synergies with other EU projects to transfer the technology in other countries? How complicated would that be?
Okay, we are obviously open to look for synergies. When we are developing new technologies, it's also very important to take care with all the issues regarding with exploitation plans, APR conditions, patents, and so on. But we are totally open. We are collaborating with several projects. We have been with other projects in events, and our idea is to be open for collaboration.
Okay. We're gonna answer 2 more questions, and I think this Q&A session went longer than we anticipated. So from Andre, we have a question. Since that 60% of the waste from plastics comes from packaging, did you perform any testing regarding innovation A?
Could you repeat me the question again, please?
So since 60% of the waste, plastic waste, comes from packaging, did you perform testing on innovation A?
No, the idea of polynSPIRE is not been focusing on plastic packaging, and it's not because we are thinking that plastic packaging is not relevant, because obviously it's the stream that produces the bigger amount of waste. Is because we are or we wanted to propose technologies for other plastic that have other requirements in terms of recyclability, as polyamides and polyurethanes. We are covering some issues regarding with polyolefins and plastic packaging in innovation C into the steel sector, but focus on chemical recycling. We are not covering plastic packaging, because we will prefer to focus on these other type of polymers that are, let's say, more difficult to recycle because of the type of materials that they are, the type of application that they are using.
Okay, and last question coming from Giovanni. What is the time of the recycling process in order to transform the polymer back to monomer?
Okay, at this moment, the time is not representative, because we are only made some tests on smaller and intermediate scale, but we are thinking about between 30-40 minutes for the lab scale, but we are dealing with a very small amount and not, let's say, optimized reactor. I think about the schedule, it will be, let's say, some dozens of minutes per batch. But I cannot confirm the final time scale, because we will need to work still on the optimization and scaling up of the reactors.
Okay. So we answered, I think, closely to 30 questions. Take this opportunity to thank you, Tatiana. It was a pleasure to host you and to bring closer polynSPIRE project to the general public and all the companies and, of course, people that are working in the industry. Also, in my name and in the name of UPC, I would like to thank our audience for taking a part in our webinar. Of course, we will continue to organize webinars on interesting topics and latest developments in our industry. So until the next time, I wish you a nice day. Thank you, Tatiana.
Okay, thank you again to all of you for your assistance. It will be also a pleasure to share with you a little information about polynSPIRE. Thank you.
Thank you. Goodbye, everyone.